What's really magical about a shared world game like Sea of Thieves is where you see another ship on the horizon and you see those sails. You get this spine-tingling moment of like, oh my god, that's another crew, because you know it's real players, because our multiplayer game brings them all together in the same world.
Early on in development, one of the key metrics we came up with for player enjoyment was what we call the engagement rate, and it's the amount of time that a player plays for before they see another crew. We determined that a good session would be about 20 minutes. So you should join the Sea of Thieves, and within about 20 minutes, you should encounter somebody else also playing. By keeping the number of crews on a server consistent, we can manage that engagement rate and ensure that people have a good experience all the time. Unlike a typical multiplayer game, Sea of Thieves servers run for days at a time, and players join and leave those servers as they join and leave the world. PlayFab multiplayer servers provides a background standby set of servers that are always ready for us to bring online. We can go from tens of servers to thousands of servers in a very short period of time. We try to ensure that players have the lowest latency to the servers as possible. So we deploy into 6 data centers, and we have a wide region around the world. Wherever players are, there's generally a Sea of Thieves server near to them.
It became very apparent we had a large community of players building in South America. We were able to bring on a location in Brazil within a matter of hours.
We just asked them to stand us up in another data center, and it happens. As players are playing, some of the telemetry that comes out from the servers is how many crews are playing on that server, where they are, and then we have our own service in Azure Service Fabric that monitors all that information and makes decisions about whether to migrate a crew or not.
We don't want to leave you playing on a server on your own with nobody else to encounter. So this is where our server migration technology really comes in. This technology is perhaps not actually apparent to the players. There's a poem that pops up on the screen, and that is basically when you're being moved from one server to another.
Migrating crews means that every single feature has to be designed to take migration into account. If you encounter a barrel on an island and it's got 4 cannonballs and 3 bananas or whatever in it, and then you go back to your ship, and then we migrate that ship. If you change your mind and go back to that island, it needs to have 4 cannonballs and 3 bananas in that barrel, right? People that just write the spawning and the information about the barrels need to take into account that that information might get migrated at some point. Early on in the development process, we developed a whole bunch of extensions that allow us to set up crews in particular states and then force a migration and then assert that conditions were true. So we could say, yes, the sails are raised, or yes, the capstan is raised or lowered. We can validate that all these things happen correctly. Another advantage of migrating crews and keeping crews together and maintaining density of servers is that it allows us to disregard servers that we aren't using and keep the cost of the game down. When it comes to updating the game, there are 3 different sets of updates that we might need to apply. The first is when we have to do a complete update to the game client, the executable that's on a player's Xbox or PC. The next set is if we find an issue with a server, we do what's called a rolling server deployment. Through PlayFab multiplayer servers, we can put a new server into play. We can start directing players to those new servers and let the old servers die off without interrupting anybody. And then finally is our own services that are hosted in Service Fabric. Azure Service Fabric provides a cluster of servers to host the services that we make here at Rare. Our server matchmaking functionality, our migration functionality, our commerce functionality, the player's progress that is persistent between their sessions is stored using our services. We will take one of our services like the commendation service and we'll say we need 6 instances of that service running. Azure Service Fabric will decide which of those nodes to deploy those 6 services on based on what other services are also on those nodes and also how they might be updated or how those nodes might fail. They won't impact other instances that are running. That allows us to be very responsive to the things that are happening within the game.
When we set out to build Sea of Thieves, we set out to create fans with it. We did a number of technical alphas and we did a number of betas where we were essentially running the live game on live servers with real players. And we did that for a number of reasons, to get player feedback, seeing how players would act and what they would do. And then you've got all of the development benefits of that.
The game client and the game server are written in Unreal Engine, and they are both connected to Azure Service Fabric via WebSockets. So we have a live connection between the game and our services. The first version of the game that we put out was just an island with just some water coming over it. It had the default characters from Unreal Engine in it, but we pushed that all the way through our continuous pipeline, and we figured out how to ship the game very early on. And then Week on week, we added, the man starts looking like a pirate, the ship starts to appear, more islands start to appear as it went on for a process of 2 years. Keeping that pace up and keeping that delivery of the game up was really hard work, but led to a really high quality experience all the way through the testing process.
One of the critical things to our project that's really helped our speed of iteration has been our CI/CD pipeline. We use TeamCity to build our title and manage our built artifacts. And then for deployment, we use a third-party product called Octopus Deploy. These are basically indispensable tools for us. Being able to hotfix a service, check it in, build the code, have it deployed within about 15 to 20 minutes has been an absolutely indispensable capability.
One of the things that we have in the game as part of our continuous delivery and continuous integration pipeline, we use toggles to make sure we only have one package that's used in all of our environments. So as we're working on a campaign, we will toggle it on for the environments where we're testing it, but it will be toggled off for the public.
There's a great opportunity to really reach customers with information and experiences that are relevant to them. An instrumental part of that is our business intelligence stack, where we're able to put together all of our different customer touch points and the way customers are consuming our content to really have a rich, adaptive, wraparound experience.
We have 2 sets of telemetry that come out of the game, diagnostics data, which comes from the game server and services. We also get all the performance counters, we can see all the CPU usage, memory usage, network usage, all that kind of stuff. And we monitor that very closely when we release a new patch.
We can use that data to react if we need to message players to say, hey, there's an issue, we're working on it. If there is an issue, we can drill further into that data, maybe isolate to a particular area of the title that's having a problem, make a fix in our source tree, push that through our CI/CD pipeline.
We also have the gameplay telemetry that comes out of the game client and the game server. And that's player interacted with the cannon, it's the speed that the ship's traveling. All the game telemetry is fed into our BI pipeline, and then we use Azure Data Explorer that allows us to see changes and query that data in pretty much real time. So when we launch a new campaign, we use that sort of telemetry to say, okay, people have discovered the campaign, they're at this stage in the campaign, the next stage people have completed the campaign. It allows us to say, has this been a successful campaign or not?
Developing a title like Sea of Thieves is a massive undertaking. There is a lot of code, there's a lot of development effort put into it. We don't want to reinvent the wheel wherever there's a solution available. We'd look to the open source community and open source offerings.
All of our game services that we use to store data about the player's session that we want to persist between games, we tend to store in Redis, and Azure allows us to do that.
Azure, from the perspective of a developer, is a super useful platform. The fact that I can spin up a VM or an instance of Service Fabric or a Redis cluster and start working with real Azure services, real integrations, because I've been developing with Azure from the outset, there's no surprises.
The cloud is constantly evolving. It either makes it cheaper for us or more powerful for us.
With Sea of Thieves, we're beginning to see a new generation of games that you couldn't execute without the cloud. We've got the ability to update the game and keep on adding new content to make sure that the game is fresh year after year and that we've got a title that's actually evergreen.
The cloud allows us to deliver the servers at scale and the services at scale. We could not have bought the servers that we would have needed to just support our development process, never mind the production needs. This game would not be possible without Azure.